record to the cloud. All right.
Okay. Well, welcome to the January 19th, 2021 session of Tangerine SDR and HamSci Personal Space Weather Station Technical Working Group. My name is Dave, KV0S, and this week I got another magnetometer set from Scotty. Um, and I hooked it up and it's been working since I got it about 3 or 4 days now. And so I actually have two sets running right now. One, the sensor is inside the house, and the other one's out in the yard. So um, I didn't have two long cables. So, uh, but I've been testing both units. And interestingly, the numbers are not that different between the two units. So that's a good thing to know. Anyway, so that's about it for me. I've been doing a little programming on the my radio simulators, so slowly making progress, but we'll get there. Okay, next on the list we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. I don't think too much to report this week. I have been working a bit on the traveling atmospheric disturbance, RBN, WhisperNet, and now PSK reporter data project that I've been working on. And we now have the invited talks and tutorial speakers for the HamSci workshop all lined up. I just have to get them put onto the website, but we have that set now. So we have Dr. Michael Rahanami, who is my PhD advisor at Virginia Tech. He is going to be talking about mid-latitude ionospheric science. We have Joe Dzekiewicz, K1YOW, who will be talking about his sporadic E-work, which he published in CQ magazine recently. And then Dr. Elizabeth Bruton, who is curator at the Science Museum London and a friend of Bill Lyle's, who will be talking about the history of radio, which is her expertise. So
Very good.
we're
Sounds
looking,
good.
yeah, and so we are now open for abstracts on the HamSci workshop. Um, as I said, I will be coordinating with the different like technical people, so we'll have a report on the Tangerine SDR, we'll have a report on the magnetometer and things like that. But if you have some other contributed abstract you'd like to submit, please go to hamsci.org /hamsci 2021 and submit your abstract. W2NF, back to net.
Fine business. Next on the list we have Bill. We haven't seen Bill for a little bit. AB4EJ. Welcome back, Bill.
Oh, thank you. Yeah, last week I was watching Alabama win its 18th national championship in college football. That was fun. Other than that, I've been working on putting in antennas. I've got the MFJ 1886 loop antenna working. Got it hooked up to the Grape. It has less signal strength than the full-size 80-meter dipole I had it hooked up to before. Not too surprising, but the thing about the 1886 is that it has a wide bandwidth, so you could use it a single antenna to monitor, your 160 through 30 megahertz. I think you probably want to use the other antenna connection for 6 meters, and so made some progress with that. So I got that up and running. Also put in the base for an 80-meter vertical that I'm working on building. I will work on that a little bit more. That's supposed to come in tomorrow, the parts I need for that. And I also have got a first pass outline draft of the NASA proposal. And I would have more, but I kind of been hanging back to see if Nathaniel got any feedback from NASA, which I'm going to, because the time is, the clock keeps ticking, I'm going to keep working on this, and I'll just put a lot of stuff into it with the idea that it can be edited down fairly nicely and fairly quickly if and when we get any guidance from them. If we don't, I'll just go ahead and make it as is, And one question I did have for Nathaniel. Now, this 10-page proposal, we were able to submit that as a PDF, right? Which means we could use figures. Isn't that
Yes,
true? Okay,
that's
good.
true.
I wanted to just make sure on that. Okay, back to Nat.
Very good. Well, next on the list, we have Dan in for XWE. Go ahead, Dan. Boy, you got some noise on your line. Okay, I'll come back to you. Next on the list, we have Daniel Fox. Go ahead, Daniel. Your mic muted.
Yes, I got it. This is the first time I've actually dropped in on one of these meetings, so I'm kind of don't know what I can say.
Okay. Well, we like to have each participant say a little bit at the beginning. That's just so we've just have a roll call. If that's all you want to say, that's fine.
Yeah, I've been interested in, the progress of the TangerineSDR.
Yes. Well, we'll talk about that in a little bit. So I'll continue down the list. Next on the list, we have Dave, KD0EAG. Go ahead, Dave.
Hello, everyone. I've been writing code and running interference for my mother. It takes a lot of time, but that's pretty much it, and a few emails. So that's what I've been doing. Back over to you.
Fine business. And Dave, I've been running version 15 on both my magnetometers, and it's working fine on either one, both of them.
Okay. I still haven't got the moving average in there like I should have.
Yeah.
But I got your changes into it.
Good.
In the formatting, I think.
Okay. Next on the list is Dave, N1HAC. Go ahead, Dave.
Hello all. Busy on a number of different fronts, but setting up a VLF receiver system, playing with various ideas there. And I have a Red Battaya running, and I'm looking to get a USRP running. So a lot of radio work, and all I presume ultimately related to Tangerine. Back to Nat.
Very
What
good.
are you doing for the? A really quick question. What are you running the Red Battaya for?
Various things, but I want to try some various receiver ideas. I also noticed it has some pulse height analyzer code in it that we can use for lightning research.
Yes.
But yeah, I want to get some receiver ideas, see if I can get them running. And then USRP, I have retrieved that from the lab and want to set that up as a chirp sounder, as we've discussed.
Nathaniel, I'll jump in there. I also run a Red Battaya as a multi-band whisper receiver, and I've been doing that continuously 6 months or more.
That's great.
Yeah, one thing I'll ask about the Red Battaya, I noticed there's a couple of SDR applications for it. One is just receiver and one is transceiver, and the transceiver goes to higher frequency than the receiver. Do people have experience with that side of it? And of course, I want to be able to run up through 6 meters with it.
You should definitely be able to run up to 6 meters, no problem.
Yeah, the receiver says only up to 50 megahertz.
I don't think that
This is it.
I thought it said 60 megahertz. There's
The
also a
transceiver
couple.
does.
There's a couple different versions of
Yeah.
it. There's the
Yes.
HPSDR version, I think, and then there's another there's a different receiver version as well.
I
Yep.
think you have to be a little careful if you're going to use it to transmit on 6 meters, because I have read that it is not clean up to FCC standards if you're going to use it as a transceiver on a ham bands.
Yeah, you'd have to filter it.
Right, yeah.
Okay, well, let's go on the list. Next we have Hyomin. Kim, go ahead.
Hey, good evening. So I've been the last Thursday I went to Jenny Jump to install the magnetometer that Jules gave me. It was successful. It's been running. I can show some graph that I generated. It looks fine to me, but I'd like to have some questions for maybe Jules and Dave. And otherwise, yep, that's update for today.
Very good. And next on the list, we have John Gibbons. Go ahead, John.
Good evening. My day job caught up with me, and I've been reworking some boards for an Internet of Things class that I had designed. They screwed up the assembly again, so I have to fix it. So unfortunately, there's only 40 of them. I did spend 2.5 hours with Ben Douglas, who was that was referred to me by Nathaniel. Brought him up to speed on writing code that is going to be actually the code that's going to be receiving on the Grape 2 for the 4 radios and probably for the magnetometer stuff as well. I brought him up to speed on what I had done in the FLDigi analysis package. He fully understands that, and he's going to create a standalone and start working with that. Also in the forum, when we get some free time, I have initial data from our Grape in Mecca, specifically in Fort Collins, Colorado. It's really wild to look at, so it kind of blows your mind. Anyway, back to that.
Well, very good.
Dave
And-
W., could you please mute?
Oh.
Thank you.
Let's see. Next on the list, we have Jonathan, KC3EEY. Go ahead.
Hi, everybody. I don't have much to report. I was out of commission. I had a diverticulitis flare up, so I was in pain all week, and I couldn't really do much. But the only thing that I was really able to do was there was somebody in India who recently published a paper on VLF and earthquake precursors, and I pointed him to the 2021 HAMSI to submit his abstract. He was in one of the VLF groups that I hang out in. I also got someone else. His name is Jean-Marie Pollard. He's from France. He written a lot of good material on VLF.it. And I also had him check out the HAMSI Telecom to see if he wanted to register. Other than that, I don't have much to report. Back to the minute.
Fine business. And next on the list, we have Jules, K2KGL. Go ahead, Jules.
Actually KGJ, but it's a tongue twister.
Sorry, Jules.
Yeah, that's all right. Busy week. I did manage to get the file naming convention correct on the magnetometer files I'm generating, thanks to John's notes. Then I had the diversions. I have to help my son with his maple sugar bush and a remote vacuum and temperature monitoring system based on Digi's XP modules that we're working with, and trying to get a 160 meter 9-foot magnetic loop working for a AREC Eastern New York section next week. And I'm also looking, if anybody knows, for a relatively inexpensive 2 gig sample per 1.5 to 2 gig sample per second DAC and associated FPGA. I need to generate some 20 nanosecond, 200 megahertz pulses. Anyway, that's it. Back to Net.
Fine business. I will tell you, Jules, KGL was my father's initials, so that sticks in my head. Sorry. Next on the list is Michael, AAAK. Go ahead.
Well, thanks, Dave. Greetings to everyone on the conference, and welcome to Dan Fox. I've been still trying to chase down my intermittent system crashes for my AMD Ryzen 7 on Linux box. That's been a real challenge. Back to you, Dave.
Well, good luck.
Yeah.
I know you'll figure it out. So, okay, next on the list would be Scotty, W2DFI. Go ahead, Scotty.
Hello there. Can you hear me okay?
Yes.
Okay. Not a lot happened this week. I sent you some boards. I see that you got them. So
Yeah, you weren't here when I did my thing, but I have them running. They've been running for about 4 or 5 days now. So
okay.
They're running inside. I don't have the remote board outside. They're in the shack.
But I took a look at the boards you sent me. I can't really see anything wrong with the R and the actual module.
Yeah.
From PNI.
Yeah.
But on the base module, R1 is lifted off one of its pads.
Yeah, that was the one that had water on it.
Right. So did you actually get on there and freeze? Is that what happened?
No, it filled. It was in a tube outside, and the tube filled up with water.
Wow, because the resistor is actually one of the connections is broken and is twisted off of the pad, so it's still there, but it's not making contact on the two pads. And of course, R1 is the SDA pull-up, so that would make the thing totally non-functional without that resistor.
Now, the PNI that you have was not the one that was in the tube when it.
Right, that's the one that I sent you that was bad, right?
Well, it would detect, but it produces no numbers on any of the. So the clock worked. I can't remember if the clock worked, but the magnetometer never gave any numbers.
So it gave all zeros or
errors.
Errors.
Yeah, yeah.
But but the serial, the I2C port worked though, right?
Yes. The I2C port worked, but the rest of it didn't.
Almost like the magnetics were not connected. Right?
And that was right after I got it. I hadn't done anything with it, and it did that. And
that's I might try sending that back because that was a defective one. All I did was solder on the two.
Well, what I did is I already had a PNI board, so I switched my other PNI board, and everything worked then.
Okay, so it was defective from the factory, from what I can tell, because I checked the joints that I did, and they looked fine.
Yes.
And if it talked I2C, then that's probably either the chip didn't get soldered down right, or one or more of the magnetics. And since you said it was errors in all axes, right?
Yes.
So it sounds like the chip has some kind of problem.
Yeah.
So, okay, well, other than that, just been trying to get a few of the dregs of other projects wrapped up and get some infrastructure. I call it infrastructure work. That means like a place on the bench that's wide enough that you can actually put something. Like John's bench there. He's got just like a little opening there, and then it's all stacked up like this. Yeah. But you got to have that opening and clear it out. So I'm trying to get that done and get the space to put the other computer on so that you and I can start working on the loader, which is pretty much the next. I mean, I still have to finish to do the final checking on the schematic, but I have to do the project first to make sure all the pins are connected right.
Correct.
And then I want to touch base with John Ackerman and with Jonathan Rizzo on the two connector pinouts and make sure we get those all squared away. Okay. They're pretty much nailed down, and I guess John, and in OBJ, you want the pinout also of the Raspberry Pi, and I have all that. I just been trying to catch up, and I'm still not up to 100% capacity here. thing just, you have good days and you have bad days, you know, and you hang on, and
Yeah.
sometimes you just, you can't do it, and do what you can. So anyway, trying to catch up and get things rolling again. So back to you, Dave.
Definitely
Scotty,
in the pin on that. So
Okay.
I'll be in touch because I have a pin out that I'm going to be creating for the next board. So
Okay.
I want to exchange that to make sure we're
I just
not.
want to make sure that you're, will be able to use the, the, well, I'll be able to put the magnetometer on either of the two boards, mainly
Right.
is what it is. So I want to make sure I have enough pins on both of them that are compatible. And then actually your daughter card, I want to make sure that I have enough Raspberry Pi pins so that when you plug your Grape board on, I can connect to all of them, so that at least we have a hope of doing something with it.
Exactly. We'll communicate on that offline.
Yeah. Okay.
Scotty, I had one other thing to let you know. I had a Raspberry Pi 4 with Ubuntu 20 on it, and plugged in the magnetometer board, and it ran Dave's software just fine. And then I disconnected that and plugged it into my Xavier Nano, and it worked just fine. It's working right now on that one just fine.
Oh, good. So
there's several
four
boards. We don't have
pins
to.
that we use are the 4 pins that everybody uses.
Yes. Well, I thought I'd try it. So see what.
Oh, good.
So,
good.
and my other one is running on an Odroid N2. So.
Yeah, I used an Odroid N2 to do all the testing for all the boards, and it worked there. So I was running Dave's KD0AJ software, and it was great for debug.
That's what I'm running as well. So just thought I'd let you know. Now we have Tom, N5EG.
Oh,
Go ahead,
good
Tom.
evening. Let's see, this week, Bill and I exchanged a bunch of emails on a protocol for setting and reading the module and ASIC registers via the data engine. I coded that up UDP in Python, and I've got the module unit test working so that the graphics utility in WX Python can go set and read all of the registers on the receiver independent of anything else going on. So Bill and I had 1 or 2 questions of Scotty we need to resolve. We can nail down the protocol and tie the ribbons on some of the code. So that's it for the week.
Okay, well, unless somebody else snuck in here, I think I've called on everybody, so we're open for general discussion.
How about Dan? He came back.
Oh, Dan, yes. Did you get your audio?
I think I did. How's it sound?
Yes, you're good.
Yeah,
you sounded like Mickey Mouse the first time.
Oh, that's bad. Well, I have this camera that has a built-in microphone, and I was trying to use the microphone. I thought I used it a couple weeks ago, and it worked fine, but it obviously doesn't work very well. 2 things. There is a new version of the Raspberry Pi OS out there. It's the, I think it's called the 110 version or 112. I'm not sure what day it was released. They don't really go by version numbers, they go by release dates. There also is a new release of the new radio. It's now up to 3.9. And I think the latest one is 3.9 release candidate 2. I was actually able to get the new radio new package, the 3.9 package, up and running on the Odroid. I've hit a few stumbling blocks with Raspberry Pi. In GNU Radio, they've made a fairly, they call it a minor change, but I think it's a really major change. They've deprecated SWIG and replaced it with PyBind 11 as the interface between C++ and Python. And it is really a mess. So I'm assuming that it will be sorted out, and I'm assuming it will be sorted out in my lifetime. But, for right now, it's not running very well. So I can't get 3.9 running on the Raspberry Pi, but I do have it running on the Odroid. There's a script for compiling it on the Odroid on my GitHub website. And that's about it from here. Back to you, Dave.
Fine business, Dan.
Yeah, there's been several, in fact, since December 15th, there has been 3 Raspbian OS updates. And I got bit by the second and third one because it turns out the ALSA driver no longer recognizes the USB audio card. I've got it that far. I have to probably manually install it, but I'm in the process of figuring that out. That's why I haven't shipped out for my Grape system, because it works, but I don't know why. And I'm hesitant to send that out to somebody and have it fall off the edge of the earth and cause problems. So if anybody is interested, I can show the WWV plots from Fort Collins if they'd like to see them.
Go ahead.
Okay, well, it looks like I can share my screen. Oh, come on. Okay, so that is not what I want to see. That's not what I want to see. That's not what I want to see. I lost it. Excuse me a moment. I've got to find it. I had it right there. Oh, there it is. Found it. Sorry about that. This is January 1st data. I think you can see that now. You notice that the frequency deviation is dead nuts on. There is a little ripple there, so it is real data. And the signal strength is pretty much consistent on 10 megahertz. That's January 1st. That's January 2nd. You'll see there's a little bit of a bobble in the signal level there, which I find interesting. And that's basically during daytime in Fort Collins is when you're seeing that little bobble in the red line, which is the frequency strength. And that was something interesting that happened at night. But again, this center line is dead nuts right on the 0 ppm line for frequency error. You can see there's a little bit of deviation there. And this is the one that proved to me that we really were measuring frequency, because we actually have a little dip here. That's January 6th. There's 7th. As you can see, there's a trend here. They all look pretty much identical, which is what exactly we were hoping for. This establishes that we can indeed measure WWV to an accuracy that is within the precision of our instrumentation, and record it and show that it does work. So that was the first 15 days of January on 10 megahertz. I'm going to probably have him change over to 5 megahertz on February 1st and do a month of 5, and then probably do a month of 2.5, and then probably do a month of 15. So,
John, I do have to question whether you're really measuring that correctly, because we get far more Doppler shift on AM signals at a megahertz.
He is like 8 miles from WWV.
Oh, okay. Ground wave.
Yeah.
You didn't say ground wave.
Yeah.
Okay.
This is Fort Collins, Colorado Mecca.
Got it.
Me and Tony set up a station. In fact, he's going to get one of the Grape 2s that does the 4-channel measuring, just to show that we are indeed doing what we think we're doing. But this is basically verification that our system works.
This is nice.
Oh, that's interesting.
This is our reference note, as I'd like to call it.
That looks very good, John.
So I'm quite
beautiful.
excited. Yeah, it doesn't get any better than that. So
yeah, that's excellent.
But I thought people would like to see that.
Yeah.
By the way, John,
repository, Nathaniel.
Thank you.
So.
By the way, John, I did think of a way to automatically upload the files to Box. We'll talk more about that in the Thursday telco.
Okay, great, fantastic.
I do
Okay.
wonder why the amplitude is changing then. If it's that close, you shouldn't have much effect.
I'll have to pass that on to Nathaniel. He's the expert on that. How's that for a handoff?
I'm not sure. I was gonna ask, is there any instrumental, like is WWV experiencing some sort of power variation?
I don't think so. If we go back here, I'm sharing again. If I go back a couple of days, the one that caught my eye, well, this one was basically just before daytime here, but there was another one that showed.
There was another one that had some variation there, and there was a
this
one.
one.
That one.
It's like, what the heck is going on with that? I mean, that's
so. I mean, you can ask them, right?
Well, the only thing I could think is you have a tractor trailer going by, giving you some multipath.
That's lasting from 5 a.m. UTC to like 11. So that's like 7 hours.
So he parked next door to it. Who knows?
Breaker.
It'll be interesting to see when you get the. Well, I mean here, like it's just straight on with the spectrum. I'm sorry, guys. I just get really tired at these 9 o'clock things on Monday nights. But yeah, it'll be interesting with the Gen 2 when you get the actual spectrum plots, not just the line plots.
Yeah, but very interesting. This is
It looks like an inverse sync function.
Well, it's probably the smoothing function we're using. It tends to ring. So
okay,
right.
Some of that
Might have been a dropout.
That's entirely possible.
Yeah.
But see, that was on the 3rd of January. So the second had also some stuff going on up in here. And that was during our daytime, which would have been his. Let's see, 12. They are. See, we're 5 hours behind. I think they're 7 hours behind.
7 hours, yeah.
So that would have been 5 a.m. there. 6 a.m. right about here. Right about sunrise, getting close. So I don't know.
Yeah, they're mountain time.
Something else to ponder.
If I might back up to Red Pitaya quickly, if people know the various transceiver SDR packages that are out there and can point me to a good one. The ones I was looking at were Pavel's, but if there are better ones to look at, if you could let me know.
Those are the only ones I know of, but as I guess you already know, he has a variety of them in there.
Yeah, well, there's a receiver and a transceiver that I found.
Yeah, but even there's 2 different versions of the receiver, I think.
Yeah. Well, one thing, they'll run on various versions of the Red Pitaya. I have one of the original 14-bit, 125 meg.
Do you need the transmit function?
I would like it, yes.
Because I know Kiwi, I don't think transmits. I think a Kiwi SDR is only
No.
receive only.
You're right.
Mm-hmm. Well, I have the Red Pitaya. Want to get it working.
How expensive is that?
Oh, I forget.
Like 300-ish or something like that?
Yeah, 300 is what I think. I paid 340 for mine.
Okay.
Yep.
That depends on which version you get.
The earlier one is a little bit cheaper, maybe $50 cheaper.
I think there's like 3 different versions now. There's
a 16-bit one that's like $500.
Right,
Yes.
yeah. So that's the newest one. The 14-bit was traditionally the better one. That was the original. And now there's like is it a 10-bit or a 12-bit? That's really aimed for just like learning.
That's like the STEM model, right?
Right.
Yeah.
Yeah.
So
and then the newest one is 16-bit and the 122.88
yes.
sample.
That was the one where Hams got involved in. It was the Charlie 25 group. And if you want to see more talks by them, the SDR Academy has a number of talks on their use of the red battalion.
Yeah, according to their website, they got a 125-10, a 125-14, a 122-16, and then there's a Signal Lab 250-12. And I think that's got a zinc on it. So
yeah,
it's a different
Right.
one. So they've got basically the 125 megahertz 10 and 14 bit models, and then they got the 122.88 at 16 bits.
Yes.
And they don't have the prices on here. They just have the comparison of the boards.
Do they do a comparison of the noise floor of the 16-bit versus the 14-bit? Does it really get you anything?
I
mean, are they engineering bits or are they marketing bits?
Yeah. Let's see, full scale voltage range is less on the 16-bit. It's plus or minus 1 volt and plus or minus 20 volts. I don't know what that means. Is an attenuator maybe? And there's half a volt peak to peak for the 16-bit, but they don't have a noise floor measurement.
Okay.
I'm looking. They all have ESD protection.
Yeah, when I was looking at the Tangerine ADCs, the 14 and the 16-bit ones had basically the identical effective number of bits.
Especially at those sample rates, it doesn't surprise me. It's really hard to get that noise floor down.
They also had pretty much identical dynamic range.
They're pretty good for the price, but I still think a Hermes or an IQ2 outperform them.
Yeah, and I think I told you guys this before, but when the linear tech guys came in, a couple of 3 years ago, which is because the Hermes was like 2013. Okay, so it's like 7 years ago now. And they came in about 4 years after that. So what, like 2017?
Yes.
And I asked them right out, I said, okay, if I was going to build this new board today, and I was going to put the flagship best ADC on it from you guys, which one should I use? And the answer was the 2208. They hadn't come out with anything better in 4 years that would beat it out in terms of noise was their biggest problem. So I don't know today. It'd be interesting to ask them the same question today.
Actually, I have a friend I worked with at Keithley for 24 years. He is now an FAE for analog devices, which owns Linear Tech.
Right.
And I'm actually working with him on the front end for the Grape 2, because he's going to be working with me on getting the A to D I want to use. So I will pose him the question.
Yeah, it'd be interesting to see what he would, and he, of course they have a bigger portfolio now because they've got all of analog devices stuff. So
yeah,
and of course the linear tech guys were never going to point me to an analog devices part back then. So
then correct, yeah. Now they're interchangeable. So that's why I'm going to ask him again.
It would be interesting to see if we wanted to build the equivalent of an HPSDR version. Take Tom's board and put the biggest, fanciest one. Because I know Flex has a 245 megahertz sample rate. They have double the sample rate that we do. And I don't know whether they use a TI or an analog devices part in their front end, but it's got to be pretty pricey. But probably less than it was 5 years ago.
Yeah, when I priced that particular chip several years ago, and I think it was around $150 for the
That
chip.
was the 245 megahertz one?
Yeah.
Okay.
So it may have changed since then, of course.
And that's
I know I've worked with TI converters at 250 and 1.5 gig.
And were they 16-bit, the 250?
250 was 16-bit, is 16-bit, and the 1.5 gig I think is a 12-bit.
Because initially I was looking at a TI part. It was a 4-channel simultaneous sample. So all 4 channels, when you told it to go, would sample at the same time. It was 16-bit. And of course, I was only looking for a 16 kilohertz sample rate. It goes up, I think, to 765 kilohertz or something like that. But it's 16-bit and it had a pretty good noise floor.
That sounds like the one Jonathan was looking at.
Yeah, the one I was after, though, I want to give it a trigger pulse. I want to have it grab all 4 inputs simultaneously.
Mm-hmm.
So,
well, any audio DACs, they do that.
yeah,
You have to.
Yep, that's what I'm after.
Or ADCs.
So have you picked the chip yet, John?
Not yet. I'm still fighting with my friend at at Analog Devices. So, in fact, I'll be getting on the line with him probably tomorrow or Wednesday, and we're gonna start duking that up over if he can do something better for me.
What part is this you're working with?
This is the A to D that's going to be doing the analog sampling of the output of the 4 mixers for my 4 IF radios.
Oh, okay. At what sample rate?
Right now, they're talking 8 kilohertz, 16-bit. So I got 416.
Oh, okay. Are you using instrumentation ADCs or audio?
Audio, definitely audio. The instrumentation
Oh,
was
okay.
too noisy.
So are you going to use the
I used to be with that group.
Oh, okay.
All right, so
I'd have to ask you some questions.
Perhaps.
So John, are you going to consider using the same one that Jonathan's going to use, or is?
I don't know what he's using yet. Like I say, I'm just starting to re-dig into it because I'm starting to finally get some traction. Once I get these 4 Pi shipped, I'm going to be diving into that pretty hard.
I don't know if Jonathan's still here, but he had one picked out, I think, that went up to 768K, and it was a 4-channel one also.
Okay.
And it was very reasonably priced.
Yeah, this wasn't expensive. I won't say.
David, do you remember what that was?
Yeah, we were looking at the TI part.
Okay.
We looked at AKM and Cirrus, and they had their problems. And
well, AKM had their factory burned down. That was
yeah, they had the factory burned down. Cirrus was not being honest about their specs, and TI seemed to have the best match. But John, what is the part number that you're looking at? Do you remember?
I'm trying to find it even as we speak. Running through my TI data sheets here.
There actually have been 2 audio groups. I was part of the digital audio, which was the professional and consumer. Then there was the computer group, and they've been combined since.
Okay, I think it is it's actually a TI/Burr Brown part.
Oh, okay.
It's a TLV 320 ADC 6140 quad channel 768 kilohertz.
That sounds like the one Jonathan was using.
Yeah, he just posted that in the chat.
I thought you were saying you were working with Analog Devices.
I thought it was Analog Devices, but
well, we've gone around.
I was the one I was looking at, and I was challenging my friend from Analog Devices to get me a better one.
Ah.
Well, we went around the horn a couple times. You know, like David said, with different ones.
Yeah, I can tell you, Analog won't have a better one than the TI one. We weren't, for whatever reason, the powers that be wouldn't let us build a really good ADC.
So
we made the best DACs, but got shut down on the ADCs.
So Jonathan, what did that cost you, remember?
On DigiKey for low quantities, I think it's $12 a piece.
That sounds.
Yeah, they're pretty cheap.
Yeah.
And that's a 4-channel.
So is that something you might be able to use, John? I mean,
that's what actually I'm looking at. I think I've ordered some parts already for it, and I think I've got the development board here someplace.
That would be pretty cool if you use the same one.
I've also got the dev board too, John. One thing to keep in mind, it will not work as a regular USB audio sound card.
Right.
Unless you use the evaluation software to set it that way, and it only works in Windows.
Okay. Yeah, I think this is a Stellaris development kit. So I got it here someplace because I was just looking at the data sheet. But that's the next step after I get my I'm actively doing the design now for the front end antenna amplifier filter / distribution, 4-channel distribution to the 4 mixers. Because I want to get one of my antennas back in the backyards because I got them all tied up with my Raspberry Pis and grapes. So I want to get my antennas back. So I got to get that going pretty quick. But yeah, that's the A to D I'm planning on tying to the output of the mixers, the Gilbert cells or whatever you want to call them.
So I got the red pitaya prices here. The 125-14 is 275 euros. The 250-12 is
Yeah, it's about what I paid for it.
yeah, that's the 250-12 is 1,500 euros.
Oh,
yeah. Because they come with different stuff depending on what you buy. The 122-16 standard kit's 499 euros. And that's the only 16-bit one I see listed here, but I haven't, they've got them split up into different tabs. So yeah, so for radio amateurs, there's the 122-16 kit, which is the 122.88 megahertz 16-bit, that's 500 euros. And then they've got the 125-14 as a transceiver basic kit, and that's 576 euros, but that's a whole kit with a bunch of stuff, as opposed to the 122-16, it looks like it's just the board. So you supply all the extra stuff, but it's because it's got a bunch of test and measurement instruments included, like the oscilloscope, and so it's got an LCD display. It's got looks like it's got one of those network analyzers. Have you seen those? You can buy for like under $100 on eBay or on eBay.
Right.
And then there's
like that.
NOVNA.
They have a STEM Lab SDR transceiver for 309 euros, which is a 10-watt, 160 to 10 meter transceiver. But it's based on the 125-14. So it doesn't,
a really nice whisper station.
Yeah, it doesn't go up to 6 meters, but it would still cover the HF with.
By the way, Mauser stocks red pitaya.
Oh, and with no markups.
Doesn't look like it.
Oh, that's cool.
Make
you can get it tomorrow then.
Yeah.
And they have a 125-14 SDR kit, which is just the basic kit for 300 euros.
Yeah, I have just a basic board and was looking to put other stuff around it.
So is yours a 14-bit or a 16?
14. Yeah, it's the 125-14.
Okay.
The 125-14-bit was how much, Scotty?
That was 275, I think.
Euros.
Basic kit was 300 euros.
Oh, okay.
And I don't know what the exchange rate is these days, but.
Well, I'm trying to find the 125-14. The starter kit is $324 at Mauser.
That sounds like it's the it's a STEM Lab 125-14.
Correct.
Yeah, that's the.
That has some additional stuff with it.
Yeah, it has. Looks like mostly just like an Ethernet cable and a headphone jack and an antenna connector, antenna adapter. Oh, and an SD card. Yeah, so it's pretty much. Oh yeah, here we go. Red pitaya board, impedance transformer board, SD card, a 16 gig class 10, an Ethernet cable, and a 5-volt 2-amp wall wart with the USA and EU adapters. And that's probably what you're getting at DigiKey, right, for 329 or whatever.
It's at Mauser, but 324, yeah.
24.
It's the STEM Lab 125-14 starter kit. They don't seem to have just the raw board here. They have the starter kit.
Yeah. The 16-bit one, you can get the raw board, I think. This first kit, see what it shows. They sell the raw board and the power supply and the SD card and the Ethernet cable. That's for 500 euros, 499, and that's the 16-bit one.
Mm-hmm. Yeah, that 16-bit one's pricey.
More expensive than we're going to be.
Yeah.
But maybe not by the time you get all the options on ours. I know the clock module is looking like it's going to be pretty expensive.
Where is the development of the clock module? Because that's going to be a
Well,
gating factor for me.
John got most of the design done, and then he had some eye trouble.
Oh,
He was having some. He had an operation on his eye. He has a drain tube, and it got clogged, so they had to go in and do something to fix it. So he's been kind of off the air for a while, but that's been a while ago. So I'm hoping that we're going to revive it this week and get everything nailed down so we can figure out what the cost is going to be. Because even early on, we can get a cost of the BOM, even if we don't have everything complete.
right.
So get an estimate, and then we can estimate what the retail cost is going to be once we know the BOM cost. And
I hadn't seen much out of him since we had the discussion on the clock card.
yeah, he's been having difficulty with his eyes, and he can't.
Right.
He says trying to work on the computer with one eye is really hard.
Yeah.
And, well, I can imagine it's hard enough strain with you have two eyes, and if you have one, it must really just give you headaches and
Oh yeah.
really fast.
Good.
So I got to get with him. In fact, I'm going to do that tomorrow. Get with him and see where he's at medically. So
Yeah. Well, I'll be interested to see how he's implemented some of the things we were talking about.
yeah, so maybe next week I can give you guys an update on where he's at. Unless I can, a nice hat, John. Unless I can con him into showing up again and giving us an update in person, which would be nice. How do you do that hat, John?
It's a video filter. When you pull up the video stuff, there's virtual backgrounds, which everybody uses, but right next to it is the video filters. And you
I mean, how do you place it on your head?
You just turn it on and it tracks you.
Oh no.
Oh dear.
Well, you see, this is like LEDs in sneakers. It's like we have all this great technology, and look, we put smiley faces up and hats and surfing backgrounds, and it's like.
Hey, I lost my macular vision in the left eye about 10, 15 years ago, and I'm down to basically left half of the vision in the left eye. It's peripheral. I've got it, but right eye is my only good eye.
Yeah.
I do surface mount.
So your brain compensates?
Yep.
Wow, it's amazing.
Mine works too.
Oh, you have a real hat. That's cheating.
He's got real hardware. That's cheating.
That's good software he's got.
Man, better than a transporter.
Yeah, it's a soft hat, not a hard hat.
Yeah, I'd be interested to see Hyomin's graphs if he's got them available.
Yeah, sure. I can share the too.
By the way, did anyone do the VHF contest? Speaking of 6 meters.
Yeah, I got a few contacts, and there was the e-skip opening around 7 o'clock on Saturday evening.
Yeah, I got a few, but I was hearing a lot more than I was able to contact.
Same here.
Mostly just northeast, but I could see Illinois, and I could see down south Georgia and such, but didn't make many contacts in there.
First of all, yeah, thanks to the nice design that Jules did. It was very easy for me to install. The only challenge was to dig the hole, but
that's 1.5
that was
pipe, right? 1.5.
The length is.
No, the diameter of the 1.5 inch pipe.
Yes.
Okay. Yeah, 1.5 inch, and the length is about what?
It was a little over 2 feet.
2 feet, yeah. So this portion is sticking out of the ground, and the sensor is down below the ground. And the only thing that connects to the building is this bubble level here. And he nicely put the line that is supposed to be pointing toward the geometric north. So once I level this, what I just did is to communicate with Gil Jeffer, who was sitting inside the building. By talking to each other, I rotate the sensor in the horizontal direction until we see maximum X or minimum Y, meaning that X is along the horizontal magnetic field line, local magnetic field line. So that is the only orientation that we did. So sticking this into the ground, level it, rotate until we see minimum Y, which is pretty simple, very straightforward.
I've got a silly question. What is the correlation between magnetic field and gravity? Because obviously you use gravity to level this, but it's not the magnetic field that's, I mean, you're aligning it, but what is the correlation between the two, or don't we know?
Oh, you mean the leveling here?
Yeah.
Well, we care about the vertical down, which is directly toward the center of the Earth. So one of the coordinates of the 3 coordinates of the magnetometer is supposed to be vertically pointed radially toward the center of the Earth, and that's the same direction as gravity.
Okay.
And then
yeah, but it's not correlation. It's just definition.
Okay.
Yeah. Right. Yeah.
And then the other two are determined by the fact that the coils are mounted orthogonally to each other.
Right. That makes sense. Thank you.
So I believe the sensor, the circuit board is pointing downward, so that the surface mount Z-axis on the surface mount board is supposed to be X-axis.
So you have the north pointing downward then.
So north is pointing, I believe so, right?
Printed on the board would be pointing downward, so the
Yeah, right.
Okay.
So Y is Y, X is Z, Z is X.
Or Z is minus X.
Yeah, one of them should be minus.
Yeah, that makes sense. Yeah, it's something like that.
Yeah.
Okay. Thank you.
Okay, so oh, this is not the one.
That's going to end up confusing some users, I think.
There you go.
Yeah.
Yeah.
Well, it's going to have to be recorded in the instrument taking the data and report it consistently.
Yeah.
Well, that's with the calibration vector. If you put that in the metadata, I think would take care of it.
Mm-hmm. So I don't know if you guys have the same issue here. Of course, this is 24-hour plot, so you don't really see the jittering magnetic field over here, which might be due to the sensor characteristics. But I highly doubt that this is due to the external noise. I guess that's just characteristic sensor noise, I guess.
Yeah, is this, I'm assuming this is not an average. This is the raw data, essentially.
Yeah, this is raw data.
That's pretty much what I get.
Mm-hmm. So, okay, that's fine then. Then I did 10-second, I don't remember, I have to look at my code, but I think that I did the 10-second average, which this is the this one, sorry. Yeah, this is after the averaging, so which looks a lot better.
Yep.
And then I haven't compared this with the real magnetometer nearby. Gil Jeffer is out of town and he doesn't have access to computer or whatever. So the data are not available yet. So, but I have compared this data with the Aquino magnetometer with uncalibrated data, which looks pretty similar. So I'm happy that I think this is working fine. The only thing that I wanted to ask you is this. I don't know what this is, like sudden drop, which doesn't seem to be real, although this looks real, this looks real. I don't know what that is, but this is average data. This jump looks kind of fine, but BX, this sudden drop, I don't know if this is real or not.
No, I think it's probably not. You know, if you do walk by it, or let's say if you're within 10 feet of it and you go by with some kind of an implement, you will see changes like that.
But the change, it
So
doesn't
why
come
would
back.
it be persistent?
Right.
Well, if the thing is left there now, yeah, I'm not sure why you'd see that. That could be. I doubt if it's any problem with the magnetometer itself. Could be something else. The only time I've seen changes like that is when I've taken a wheelbarrow, parked it down for several hours by the magnetometer, and that's about it. If it's a transient, there's just usually a spike.
Yeah, I was going to say
Yeah.
somebody might have parked a car nearby.
Just for grins and giggles, you might plot the temperature on the sensor to see if something
I
changes.
mean, this is highly controlled. I don't know. Yeah, I have to ask Gil whether I know that this is close to parking lot, but I don't know how much of traffic there is over there. I kind of highly doubt that. But this is like almost like 50 nanotesla difference.
Yeah,
which is
that's not unusual with man-made interference. So that is, if it's something like a car, the mass of a car, and
right.
it's, let's say, within 100 feet, you'd probably get something like that.
Wow.
But it is also at 1 a.m. local time.
Space aliens.
Well, is it near
Say-
any bars?
That's
in
at
college
6
Right.
town?
Yeah,
Six
that's
or
6
six
o'clock
U-
UT. That's an unusual time for something to happen.
Well, this is astronomy club building, so maybe some show
Yeah,
up like in the middle of night. I don't know.
Even we dedicated astronomers are not likely to be setting something down at
Yeah.
1 a.m.
Yeah, but you don't really see that change in the other two axes, so I'm not sure.
Well, you can see a glitch there.
True. Yeah, no, that's true. It's about the right time. Yeah.
Is there a daily variation in the magnetic field, or is it only events that cause changes?
No, there's a diurnal change.
There is. Okay.
There is, yeah.
But not a jump like that,
Not a jump like that.
generally.
Hyomin, is this some Python code that you to do the
Yeah.
plotting?
Yes.
Are you willing to share that with us?
Oh yeah, of course. Sure.
Yes, I'd like to try that on my data.
Sure. Okay. I'll
Sounds like a good thing to put up to the GitHub. Make
take a note. Yep.
magnetometer section and just throw it up there.
Okay.
Because I would.
I'm not really.
We just discovered why they call it Jenny Jump. There's a jump in the data.
I'm not
That
really
is
a
the Jenny
native.
jump.
It's
I'm not really
there's an amusement park in Hope, New Jersey called the Land of Make Believe, and when I was young, my parents would take me there, and in the back of the amusement park is the old Jenny Jump house, so it's like a historical site, and there's a recording that would tell you the story over and over again why they called Jenny Jump. There was a young girl named Jenny there, and she would explore in the mountains, and there were also natives in the area, and so the natives one day were, I think, coming after her, and they yelled, and she was at the top of this cliff, and they yelled to her, "Jump, Jenny, jump!" so she'd get away from the natives, and she jumped off, and I think she just got away with breaking her ankle or something like that, but otherwise she saved her life and then went on from there. So that's why it's called Jenny Jump.
This looks like a data loss.
No, we do have some value over here.
Oh.
So I mean, it's not unusual to see like, intermittent spikes in magnetic field data, although this seems to be pretty long. So I don't know what that is. This is like almost like half an hour, I guess maybe 15 or 20 minutes.
Yep.
So I don't know where that comes from. If there could be a car, foot traffic, whatever that can disturb the magnetic field signal, but this seems to be pretty persistent. It's not really intermittent, short-lived disturbance. So I don't know what that is.
Yeah,
How
the
close,
interesting
how
thing,
close
it
is your
returns.
reference magnetometer there?
About like 100 feet or so.
Yeah, so you should be able to see if you see a glitch on this, you should see it on that.
Yeah. So that's my plan. So,
Overall,
but I think
yeah.
overall the performance looks fine. Although I think we picked really, really boring, quiet days, so I don't really see.
Well, solar conditions have been pretty boring too.
Right. That's what I'm saying. Yeah.
The one CME that we had go past was BC positive and just went past us.
Yeah. So hopefully the sun gets more active pretty soon. Otherwise, you'll see the very boring variation in magnetical data, especially in mid latitude here. I guess New Jersey is not that middle latitude in terms of geomagnetic location, but still. Anyways, I have so far 3 days worth of data, and then it looks fine to me, except for this like small glitches. But I think overall performance looks fine. And I really like the Jules design, which is really, really, sturdy, reliable, straightforward, easy to handle. So I guess we should go for that design scheme.
By the way,
I guess.
there's geomagnetic unrest expected according to spaceweather.com for the next 3 days. So we'll see if we get anything induced.
If you go back to the stack plots, there are dips like this in Fredericksburg and Boulder.
Do we have data available? I mean, this is like yesterday, so I don't know if there are.
I was
do we have
looking
any
at it.
Oh, okay.
Let's see
I think this seems to be local.
Yeah, you can get the Fredericksburg data is available for the full 24 hours, about 2 to 3 hours. In other words, into the next day. So about 03 to 0400 UTC, the previous day is available.
Okay.
So
I guess intermagnet, I guess.
I have
Intermagnet, right? Yeah.
one that I use that is from Tromso, but it's got links to everything else.
Tromso, you mean?
University of Tromso?
Yeah.
Oh, you mean Norway? Okay.
So if you, let me see if I can share it with you, if I can find the.
That happens to be where UHA is.
Yeah.
Coincidentally.
Where is the? Everything's buried in mine. So
I haven't plotted my data yet from the 17th, but I'll do that to see how close that is.
Where is? So, Hyomin?
Yep.
Can you turn off your sharing and I'll share this?
Sure. Where is it?
Okay. Let's see. So if you go here, Tromso Geophysical Laboratory, and you go USGS data, this is current day. And FRD is Fredericksburg, and Boulder is BOU.
Yep. I'm also looking at intermagnet. That's where Fredericksburg data is also available. So
okay.
Yeah, either
I
way.
just like this one because it has all of them in the same.
Oh yeah.
Plotted together.
Yeah.
What are the top three?
Those are very high latitude.
Oh,
Yeah,
okay.
but I'm not recognizing any of the. Oh, Sitka must be the SIT. Huh.
So, and then if you want the European ones, you can go, you got all of them here. The Russian ones, mid-Europe.
Yeah, I'm familiar with the Alaska one and the Norwegian one, Greenland.
So I've been using the USGS data.
Mm-hmm.
Yeah.
And it basically tells me that I'm expecting something. I was thinking we ought to be able to make something like this available from a web page for our sensors.
Sure.
Right.
Yeah, I think I'm looking at Fredericksburg data, and then the overall trend seems to be pretty consistent across all the magnetometers, even the scale in terms of nanotesla. So
I think it's interesting that Fredericksburg and Boulder have that little bit of a shift, couple hour shift.
They're sharing data.
Well, you know, it's
I
half a
think it could be
country.
longitudinal. Yeah.
Yeah.
Okay.
Well,
yeah, looks good.
I'll stop sharing if I can figure out how to do that. There we go. Well, I'm done. I need to go, but people can stay, I guess. I'm sure Nathaniel's about half asleep now.
Yeah, I know.
Hey, I had a class scheduled for this semester, and I only got 4 students, so they canceled it. So I don't have a class this semester.
So you're off.
I'm off. And this was the last semester I'd promised to work.
Oh, so
you're
so
a
that
free
means-
man now.
Wow.
Yeah, I may have a 1-week class in May. We'll see if that happens, but basically I'm done teaching.
Congratulations.
Yay. So quick review of the magnetometer, that since everyone is here, we were just talking about it. If I can share my screen here. This is what I have for the changes to the magnetometer board itself. So move the RJ45 to the opposite end of the board and add a 10-pin header so that Jules can leave the connector off and wire up directly to the board. Remove the grow, quick, and external 5 volts of PMOD connectors. Make provision for multiple I2C addresses on both U3 and the PNI part by bringing out the address pins to external jumpers on the board with pull-ups, and adding a 5-volt power connector to the Raspberry Pi fan, just 2-pin. And I think I got all of them. I might have forgotten one, but I remember laying in bed one morning, not feeling like getting up, and running over the list in my head and then not getting up and typing it in.
Scotty,
yeah,
would it be possible to leave the 40-pin included, but don't solder it?
Yeah, I would suggest that too. It gives you an extra option for mounting the magnetometer.
On the remote one particularly.
Yeah.
But so actually what you want to do maybe is, since the RJ45 is also through hole, you could leave both of those solderable by the user.
Yeah.
Sure.
Those are both easy to solder. So.
Yep.
And then Jules wouldn't have to take it off even if he wants to put it in the pipe.
Right. I think that's a real good idea.
But I think, we might be able to jockey this around a bit so it would fit inside the pipe, that 1.5-inch pipe, with both the connectors in place.
It'd be nicer if the 40-pin just wasn't there, though.
Well, the problem is that if you want to connect up to any additional devices, like when Jules wants to hook up like 4 of these in one big long pipe, it provides a very nice connection point.
He can solder to the hole to hole.
Well, you can do anything, but making it easy is easy. So, but if it makes it not,
well, I think that
it's no good. Right?
I think the best solution is leave the 40-pin holes there, and provide a 40-pin connector, and then leave that. That's a simple soldering.
Well, and I think what we would do is I could make it a kit, okay, kit and assemble, because some people will just absolutely not solder, okay, and they don't want to do that. But interestingly enough, those 2 pieces will be the last through hole parts on the board, except for the 2 sockets that hold the PNI. And the 40-pin connector by itself is the single most expensive to install part.
Right.
Because it basically costs about 10 cents a pin to solder anything. So
Yeah.
do the math, that connector is expensive to solder on the board. So we get rid of that and
I
say,
think
here's in a bag.
a bag of the 2 connectors
Yep.
and
Because the RJ45 also is through hole. It's pretty easy.
and then just make a few of them for people who don't want to solder.
Yeah.
Yeah.
Well, we
Somebody
have
could
lots of
solder up
volunteers,
some.
right? You want to help out somebody who doesn't want to solder, then they can ask them to solder them for them.
Yep.
Like Elecraft does, right?
Yeah.
Yep, sure.
Yeah.
Yeah, just to do not populate on the board, that's pretty easy.
Yeah, okay. You convinced me. Wait a minute. That's J6, RJ45, and was it J1? No, J9. I can't type, as you can tell. How's that?
Very good.
Perfect. Save it, save it, save it.
Looks good.
Okay. So anything that I missed other than that last one? And the 5-volt power connector, I was thinking is just a right angle 2-pin guy. And we might even just leave that off also and let the user install that if they want it.
Yeah, you could.
Yeah, less chance of shorting something out accidentally if they don't put it in.
Yeah.
And
There's a somebody who's got a Kickstarter or something. I think it may be Sequans or somebody that's been sending me things, and I guess I ordered a couple of them. A board that is designed to go on the 40-pin bus. This would be at the local end, but between the Pi 4 and the whatever you plug above it, and it has a fan there. I don't know whether that's a bad idea for our purposes.
You just sandwich it between the Pi 4 and our board, and it would blow down on the Pi 4.
Right, and it's $20. They'll be having them pretty soon. I don't know. I bought a couple of them to try, but it may be a bad idea. Who knows?
Well, the Pi 4s have to have the heat sinks and the fan, otherwise it will throttle back thermally during the boot, which takes 7 seconds. So it gets hot quick.
Yeah, but it should speed back up after that, shouldn't it?
Well, if you don't have a heatsink on it, no, it won't. I mean, you'll burn your finger just touching the case.
I
Get
hadn't.
up to 70C.
Yeah, but I'm just saying for operational purposes, and if you don't start collecting data the instant you turn on the power.
Well, the 4B has got the 4 RISC cores, and they're running at 1.5 gig if it's flat out, running full bore. So it gets toasty.
Are you
The
setting
get away with, but the 4 you cannot.
Are you setting the governors to whatever that is, high performance or?
No, I'm letting it get auto set on the Raspbian and set it.
Yeah.
I've got a little meter on the side. I can watch the speed, and they usually drop back to about 600 megahertz.
We may need to look at that when all said and done, because once you're doing radio stuff and also trying to get measurements on I2C, that's another reason why I want to do some experimenting once I ever get this C code done with some more reliable scheduling, because the standard Unix tools are not designed to control things very well.
Well, that's why in my design, I'm bringing out the 1 PPS to actually trigger the measurement event. It's a hardware trigger.
Yeah, I don't know. Well, you for yours, that might be work, but I don't know if there's anything events, interrupts on a Pi are like no way.
The latency and the variability will kill you. I mean,
Yeah.
plus or minus 100 microseconds is nothing for that.
Yeah.
So yeah,
Yeah.
that's why I'm going harder.
I've been looking at system D timers, and stuff that allow you to control better. Cron just it only lets you set once a minute or something, but some fast, I don't know, some system things that run in a separate thread. And
well, the standard system clock runs at a kilohertz. So if you want something more resolution than that, you're going to have to do something special.
Well, it's not that. It's being sure that you get or getting a better chance. The way I'm doing it right now, just by essentially reading for availability of data, creates quite a bit of jitter, and not
right.
Significant jitter anyway, and it's something I'd love to find out how to minimize. It's just the next step, I guess, once we get the other stuff done.
So I take it you're not planning to use the interrupt line.
Well, interrupt lines on a Pi, in fact, the Pi 4 is worse than a Pi 0 by all accounts. Yeah. Because with multiple cores and, and not knowing, exactly, it depends on, you might be able to play some games with affinity and reserving a core for a particular task and take it out of the range of any other tasks. So they couldn't run on it, but even that is not foolproof. In an operating system based design like this, interrupts are pretty useless, except at a, in a kind of sooner or later we'll get around to it sort of thing.
So because really the data ready is the interrupt. So it's like all the collection has been done. You program the thing to interrupt you when it's done. So I have no idea what the latency does to you there, but this the most complicated part of the board is getting the interrupt back. If you're never going to use it because it's not really usable, then maybe we should consider removing it and doing the polling only.
Yeah, I never really thought that. I never thought that was likely to be too useful. I mean, if we want to do something like that, we really have to put a little microcontroller in between, like an AMD or something that actually does the I2C and things like that. SPI, it's almost even worse. You have to. I've been looking into all this. It's just not designed for that. Linux is not designed for that. There's things you can do to reduce the impact, but nothing that can eliminate it. Or
that's why
so it would be really used if you weren't running Linux then, which is like, that's not going to be our case.
Right.
Yeah, not going to be our case. Well, if you use something, ideally something like these, what are they called? I think the Teensy 4.0, or is it something?
Arduino?
Well, not the Arduino. They're not really. There are some ARMs that you can run that have decoupled I/O that run quite fast, but you still need to run an RTOS on it. Something like free RTOS or one of those things.
Can you run free RTOS or something like that on a Pi?
It's possible. Such things probably have been done, but it's not. That's most of these Pis really have 5 processors in them. I don't know if the Pi's do, but most of the other ones, almost all these other ARM boards that run Linux, have a 5th processor. Even the Beagle boards had this. I once talked at length to them. They have an extra processor that handles the task allocation across the other CPUs, and they don't really tell you much about it, but it runs in a little, but it handles task scheduling, and getting into messing with that gets you into all kinds of weirdness, mostly undocumented weirdness, I think. And I don't know whether that's on a Pi or not. I haven't been able to figure that out.
Yeah.
Scotty, do we still have the lightning sensor in the mix?
No, we took that out a long time ago because.
Okay, I'll take it off the registration. Then I keep seeing that. I'm going to have to delete that. Okay.
Yeah, because we talked to the guy that worked at Nathaniel. Help me out here. It's Nathaniel looks like he's gone.
I'm still here.
So the guy from he worked at NOAA, I think.
Yeah, we talked to Jerry Krieger.
Mm-hmm.
Yeah. He said, forget it. It's not really worth anything.
Yeah, I've got one in one of my weather stations, and it gives you like 0 to 3 miles, 3 to 6, 6 to 9, 9 to 12, and 12 to 15.
I wouldn't even believe that. I wouldn't even believe that. I think Jonathan's VLF receiver is going to be way better for doing any of this stuff.
And I had to shut mine off because there's some frequency band that I'm tickling it with, and I'm getting constant lightning announcements. It's like, come on.
Well, he convinced me that even at like $2, it's not worth it.
No,
So.
it's not worth the headache.
Yeah.
Yeah, that uses a lookup table to estimate distance, and it's not really accurate. It's really just a toy.
Yeah.
Yeah, that's what
the antenna on it really sucks too. So yeah.
And
so, but what I'm thinking is if we're not going to plan to use the interrupt, I can just leave the traces on the board. Who cares? I just repopulate all the parts and
bring them as power. Use the other one as power again. Make use of it.
Well, I have a resistor I can put on to make it power.
Yeah.
Just use it that way. And if you really want the interrupt, you can go modify your board. Yeah. But other than that,
I'd say leave it. Don't do it.
And if you do that, then there becomes no local remote jumper. So just if you're, unless you're like Jules who wants to put like 8 of them all in one pipe, it's the local one detects that it's local and the remote one detects that it's remote, and it automatically sets the addresses. And if we bring the address pins out, then you can program up 4 of them remotely if you want.
I've always gotten these boards from companies, that especially evaluation boards that have all these jumpers and footprints, but with no explanation of what they were ever intended for. And I always wondered, what they were about. Now I understand far better how that comes to be.
And Tom made me put the explanation on the schematic, so it's there. If you want some punishment, to go read it.
Well, gentlemen, I'm going to have to split here, so I'll say 7-3. It's
I should stop sharing here.
Yeah.
7-3.
7-3.
7-3.
I would say 7-3 also.
7-3, folks. See you next week.
7-3.
All right.